linear factor. Solve this. Okay, for solve to sketch or factorize, we all need to factorize first and then solve it. Okay, use non-factor law. So again, a little bit of revision. What's the number we will try? We'll try plus minus 1, plus minus 2, plus minus 3, plus minus 5, plus minus 6, plus minus 10, plus minus 15, and plus minus 30. But this side, very unlikely to happen, okay? It must be in between 1, 2, 3, 5. So we'll start to set up this box to work on it. We have 1, -4, -11, and 30. Okay, right-hand side must be 0. Okay, right-hand side must be 0. So let's think about a number. What number do you think was to start? I'll just tell you, do not, I tell you always think about 1 or 2, yeah. Oh, as I always think about 1 first, but when you think about 1, can you see when you put 1 in, don't worry about the sign. You have 1, 4, 11, and 30. For those 4 numbers, it's very unlikely to make a 0 for you. Does that make sense? You think 1 in, and you will see 1, 4, 14, and 30. It's very unlikely to use those 4 numbers to make a 0 when you plus or subtract them. So the 1 or -1 is not a good choice to start with. Okay, you can still try it. Doesn't work. You can try 2, but it's a little bit waste of time. You can see in something like those 4 numbers, it's very unlikely to make 0. So I will start to say, when it says 2, I'll start 2. If it's not working, we'll try another one. Okay, so we have 1, and then 2 minus 4 gives me -2. -4 minus 11 is -15. -15 times 2 is -30, and I have a 0. So that one worked. And I can factorize as x minus 2, x squared minus 2x minus 15. That will give me a 0. And then I will factorize this quadratic. That gives me x minus 5 and x plus 3. Plus 3 and minus 5 gives me a -15, and minus 5 and plus 3 give me a -2. This one will work. That equals to 0. So x will be 2, 5, or -3. Have 3 solutions, 2, 5, or -3. Yeah? You mean you sub 2 in?
No, I sub -3.
You sub -3 in? And it's not working?
Okay.
Yeah, it's okay. It's not because can you see 2 is working or positive -3 is still working. If you try one of those numbers, they all worked. Okay, you can just choose one of the 3 because 2 is the smallest. I start from that one, so you can try anything. Anything within that, the red numbers will work. Okay, example 10. Example 10. We realize the right-hand side is not a 0. Okay, the right-hand side is not the 0. So I will have 2x cubed minus 5x squared plus 5x minus 2 equals to 0. What x? Oh, not to that step yet. Okay, we'll just move the 2 to that side first because I want to use non-factor law, so I must have right-hand side to be 0. Then I can start to try plus minus 1 and plus minus 2. There are only 4 possibilities I will start to try. So 2 minus 5, 5 and minus 2. Can you see you have 2, 5, 5, 2. 1 is very likely to work, or -1. It's either 1 or -1. They can make a 0 for you. So I will try 1. That is 2. 2 minus 5 give me a -3. -3 plus 5 gives me 2. 2 minus 2 gives me 0. Then I will have x minus 1. 2x squared minus 3x plus 2 equals to 0. Okay, I want 2 and 2 make a negative 3 for me. So I have 1 and 2. Wait, I'll check this first. Discriminant equals to 9 minus 4 times 2 times 2. And that's smaller than 0. You see that? 9 minus 16 is smaller than 0. So I can't really factorize that. Although it seems very likely to use 2 and 2 make a 3, but actually it doesn't work. So that is smaller than 0. Do I have it correctly? Yes. So 2x squared minus 3x plus 2, and that's smaller than 0. So if discriminant is smaller than 0, I can't factorize. Also, I can't solve for zeros. Okay, I don't have that equals to 0. I can't solve out anything. So therefore, x can only be 1 for this question. X can only be 1 for this question. Because the quadratic cannot factorize, because the discriminant is smaller than 0, therefore, even the quadratic equals to 0, I have no solutions for that quadratic. Therefore, I only have one solution, x equals to 1. Okay, for a cubic, there is only 2 possibilities. It can have 1 solution, or it can have 3 solutions. You won't have 2 solutions for a cubic. Okay, only 1 or 3. Okay, either solve for 3 solutions or 1 solutions for real numbers. Okay, let's find the linear factor. Okay, that's how you solve by using linear factors. What we have learned last lesson, like see, we have already factorized for you that one, and for this one, I can take out the x, which I have no constant term. I can remove the highest common factor as a factor here. That's 2 cases. And I can example 5 and example 6, I use the a cubed plus b cubed and a cubed minus b cubed formula. And for this 7 and 8, we use the grouping method. Okay, we group 2 of them. Use grouping method. And then the last thing we want to do is find linear factors here. Then example 11. Okay, example 11, I said choose your own ways. Okay, well, I gave you 10 examples before, and I want you to use your own ways. Okay, it's not factorized. There's no highest common factor because I got a constant. I can't use a cubed plus b cubed method because it's not in that form. The only 2 ways I can do will be grouping, either grouping or I can find the linear factor. If you think about find the linear factor, we will think about what factors worth us to try first. Okay, can you see the last number is 1089 something? It's some number really terrible and really big. Okay, it's really big. Before you think about, like, normally I won't give you some number like that and ask you to factorize. But why I put this question here? Because let's think about this number 1089. What can you think about this number? Like, this number is divisible by which one? Which number? 9. Okay, if you add all the digits, 1 plus 8 plus 9 give you 18. And 18 is divisible by 9. So this number will be divisible by 9. I can see we have a 9 in this, like the x squared term. I may start to think about, is that possible to use grouping? Because 2 and 2 for 2 can be factorized, can be grouping together. Let's use 1029 to divide 1089 to divide by 9 first. Have 18, have 2, and have 1. It gives me 1 to 1. So if I can do those 2 together, minus bracket 9x squared minus 1089 equals to 0. Okay, those 2 and those 2. Have 2x for this one. And I have x squared minus 1 to 1. Okay, I can take a 9 here. And it's x squared minus 1 to 1 equals to 0. Can you see we can use the grouping because I create like 2 same terms. That's the common factor, and I can have 2x minus 9 equals to 0. What is 1 to 1? What's the factor for 1 to 1? 11 squared. Okay, 11 squared. So it's x squared minus 11 squared. So I will have x plus 11 and x minus 11. And I have 2x minus 9. And that equals to 0. So I will recommend that you can remember the square from 11 to 15 at least. Okay, you can know what are those numbers. Okay, 11 square, 12 square, 30 square, 14 square, and 15 squares. When you see the square of those numbers, you can realize, okay, that's that number squared, and will help you to deal with factorized questions. Okay, so my x can be plus minus 11, or it can be 9 on 2. Okay, plus minus 11, or it can be 9 on 2. Okay. Let's move on to the next page. Next page is cubic. Okay, for cubic functions. So when we sketch something, like what the things we have learned so far, we learn linear, quadratic, okay, linear, quadratic, hyperbola, truncus, circle, semicircle, square root. They all look the same, right? All the graphs have the same shape. It's only like reflect or translate to different positions. But for cubic, I have two base shape. Okay, I have two base shape for cubic. So basically, cubic have two kinds of graph. Okay, first kind of graph is in the form of the point of inflection form. Okay, this form is called point of inflection form. So I'll go through two forms. That's the first one. This page is the first one. So what's this form looks like? This form looks like a quadratic, but the only difference is cubic instead of square. It exactly looks like the turning point for quadratic. But this is called the point of inflection form. Okay, this is called the point of inflection form. Okay, for quadratic we have turning point form. Turning point form can give us turning point. Then what's point of inflection form can give us? Point of inflection, okay? Point of inflection. So how do we, if that's a quadratic, turning point of quadratic form, what's the turning point? If that's a square, what's the turning point? What's the coordinates? If I have x minus h squared plus k, what's the turning point? hk. Then the point of inflection for this form is hk as well. Okay, same way as how you find the quadratic. Okay, when you have a quadratic form, turning point form for quadratic, and you find the turning point, what's the next thing you think about if you want to sketch a graph? The shape. What the shape? How many different kinds of shape you have for quadratic? You have upward or downward, okay? Up or down. Same thing happen here. After you find a point of inflections, you will think about whether it's an increased graph or decreased graph. I have another two shape for cubic as well. One looks like this. It's an increasing shape. One looks like that. It's a decreasing shape. This one gives me a greater than 0, and this one gives me a smaller than 0. Okay, makes sense. Greater than 0 increase, smaller than 0 decrease. So I have another two shape. Okay, for those two shape, I must have, okay, remember the x in the bracket must be positive. Okay, the x in the bracket must be positive. If it's negative, this equation not work. You must have the negative out first and then sketch the graph. So make sure the form exactly looks like this. In the bracket, it can only be 1x minus some number cubic. Okay. And then we'll think about, after that, we'll think about one point of inflection, second, the shape, and number 3 will be xy intercept. The xy intercept. Okay, 3 things to think about. First, point of inflection. Second, the shape, whether it's an increasing shape or it's decreasing shape. Number 3, we'll think about the xy intercept. It's actually 2 things to think about, x-intercept and y-intercept. Okay, so 4 things you need to work out for this kind of graph. And the domain and range for cubic is always R and R. Okay, always R and R, because I can take any kinds of x and it can give me infinitely large numbers or infinite small numbers. Okay, so always domain and range is R and R. You don't need to think about it. It's the same as the cube root function. Okay, cube root function. You always have R and R for domain and range. Okay, that's the idea of this, but let's sketch this graph. Okay, we have fx equals to 2x minus x minus 4 cubic plus 2. So what's the point of inflection here? 4, 2. Okay, we have 4, 2. Is that a positive or negative shape? Positive. The shape looks like this. Let's work out the x-intercept. How do we work out x-intercept? Y equals to 0. Good. So we have when y equals to 0, 2x minus 4 cubed plus 2 equals to 0. X minus 4 cubed equals to minus 1. What's x minus 4 equals to? What's cube root of minus 1? Minus 1. Okay, minus 1 times minus 1 times minus 1 equals to minus 1. So that gives you minus 1. Because it's a cube root of minus 1, that gives you minus 1. So x equals to 4 minus 1. X equals to 3. You only have minus 1. Okay, you don't have plus minus of minus 1. That's only for even root. Okay, for the odd root, you only have one solution. It's negative 1. So we will have that's 3. So the 3, 0 is the x-intercept. Let's look at the y-intercept. Is when x equals to 0. There will be some terrible numbers. Okay, so f0 gives you 2, 0 minus 4 cubed plus 2. That equals to 2, negative 4 to the power of 3 plus 2. Okay, negative 4 cubic, so 16 times 4, 64. Minus 64, minus, so 2 times minus 64 plus 2. Minus 1 to 8 plus 2. And that's minus 1 to 6. It's a really big number. So I have 0, minus 1 to 6. I'm not going to sketch this on scale, okay, in scale. So just assume like it's somewhere touches. Then let's sketch. I know all the informations now. I can sketch the graph. First you have 3, 0. 3, 0. And you have point of inflection at 4, 2. Here. And you have 0, minus 1 to 6 somewhere below here. And that's the point of inflection. So I will have graph looks like this. Well, it's not looks very nice. Okay, something like that. That's the point of inflection. That's the x-intercept. And here, let's say 0, minus 1 to 6. You try your best to show that's a point of inflection. Okay. Okay, that's the shape of the graph. Have a look at the next one. Fx equals to 3 bracket minus x minus 1 cubic plus 3 on 2. Okay, as I said, you must have positive x in the bracket. Here you have the negative x, which is not really working. So I will rearrange this equation. Fx will equals to 3. I'll take this minus 1 out. X plus 1. And then cubic 3 over 2. What that will equals to? That equals to 3 times minus 1 cubic times x plus 1 cubic plus 3 on 2. So that will give me minus 3 x plus 1 cubic plus 3 on 2. Okay, that's what I will have. So what's the point of inflection? Yeah, point of inflection is negative 1, 3 over 2. Is that a positive shape or a negative shape? Negative. So it's too big. So some shape like that. We want to find y-intercept maybe first. So when x equals to 0, f0 will equals to minus 3 times 0 plus 1 is 1, 1 cubic still 1, plus 3 over 2. And that is a minus 3 over 2. Okay, minus 3 is minus 6 over 2, plus 3 over 2 is minus 3 over 2. So I have 0 minus 3 over 2. Minus 3 over 2. Okay, let's say when fx equals to 0 or when y equals to 0. When fx equals to 0, I will have 3 minus 3 x plus 1 cubed equals to minus 3 over 2. Divide that by minus 3. That gives you a half. Okay, and then x plus 1 will equals to cube root of a half. Okay, cube root of half, is that a number greater or smaller than 1? Because I will have minus 1 plus that number, and I want to know is a positive or a negative number. Is that a positive or negative x-intercept? That number. Wait, a half is smaller or greater than 1? Smaller than 1, right? Your cube root 1 equals to 1. Then your cube root a half must be smaller than 1 because a half is smaller than root 1. Than 1. So 1 is smaller than this number. That no, wrong side. 1 is greater than that. Then your cube root must be the same sign as well. Okay, 1 is greater than that. Then your cube root of that is still in that sign, because positive side of cube is like increasing shape. The larger the number, the larger the cube root number. So is a number smaller than 1, then minus 1 plus a number smaller than 1 will still be negative. Okay, so that number is still smaller than 0. But you can't put your cube root a half in that form because we want to rationalize our denominator. So that's a cube root 2. What I should times actually? Square root 2 times square root 2 give you 2. How about cube root 2? How many times you need to times itself to become 2? Square root is you take like the second root, you times twice. Then cube root you need to times 3 times. So I will times cube root 2 and times cube root 2. So you times that and that. So x gives me minus 1 plus, that will give me a 2. Cube root 2, cube root 2, cube root 2 will give me a 2. And on the top, cube root 2 times cube root 2, I can say that's a cube root 4. Okay, times the number inside. Same, all the root is the same as square root. Okay, square root a times b equals to square root a times square root b. So you have that number. But that number is still smaller than 0. Okay, still smaller than 0. Okay, so the x-intercept is this. And it's a number smaller than 0. Okay, let's sketch the graph. Have point of inflection at -1 and -1 and 3/2, which is here. And I have 0, -3/2, which is here. And I have a really small negative x-intercept because it's quite close to 1, this number. So it's -1 plus cube root of 4/2, 0. This point is the point of inflection. Okay, so the graph will look like like this. And remember to label your xy axis. Okay, decreasing shape, point of inflection there, xy intercept at those two places. That should be the shape of the graph. This graph looks much better than the previous one because it's drawn to scale. Any questions about this type of cubic? This is the cubic in the point of inflection form. Okay. How many different forms quadratic have? How many different forms you know? Like general form, that's the thing I know. There should be 3. General form is the first one. Like ax squared plus bx plus c. What's the second one? Turning point. Yeah, turning point form was similar to this one. The last one will be x-intercept form. Okay, x-intercept form. So for cubic, same. Okay, we have general form. We have point of inflection form, and we'll also have intercept form. Okay, we also have intercept form. In other words, it's factorized form. Okay, intercept form will be the same as factorized form. So the next exercise is graph of factorized cubic. Graph of factorized cubic. That is x-intercept form. Okay, the factorized cubic gives you x-intercept. Okay, gives you x-intercept. Okay, so the whole paragraph here is like essays. I don't want to go through that, okay? When you forget how to sketch that, you will go back to read this essay. I will just tell my way how to sketch it, okay? I'll tell you what to do. I will repeat that, but not reading that. So for the first example, it's in the general form. Same as quadratic, we can never sketch things by using the general form. It's not helpful. So we either turn it into turning point form or x-intercept form. Then for this type, general form, I will turn that into x-intercept form, the factorized form. In other words, I need to factorize it. I won't turn this into point of inflection form, but because we don't really know how to make into point of inflection, not as quadratic, I can complete in the square and put into the turning point form. For cubic, the point of inflection form will given to you, or you just factorize this. Okay, factorize this. So how we can factorize this? Okay, back to the last week's content. Factorize it by using this magical box. Okay, 1, 2, -5, and -6. Right, so plus -1, plus -2, plus -3, plus -6. I will start with, which one I think you think I'll start with? Do you think 1 will work? Yes, because I have 1, 2, 5. I don't know 1 or -1, but the full number I have is 1, 2, 5, and 6. Okay, 1 and 5 can give me a 4. 2 and 6 can give me a 4. So it's very likely to work for 1 or negative 1. So I'll try 1 first. 1 times 1 is 1. 1 plus 2 is 3. 1 times 3 is 3. 3 minus that's minus 2. But that one not working because it's not a 0. So let's try minus 1. 1 minus 1 plus 2 is 1. Wait, did I make some mistakes here? 1, 2, 3 minus 2. 1, 2 minus 5 minus 6 minus 1 times that's minus 1. Minus 1 gives me 1. Minus 1 plus minus 5 is minus 6. Minus 6 times minus 1 is 6. 6 minus 6 is a 0. So minus 1 works, but positive 1 will not work. So fx will equals to x minus negative 1, which is a plus 1. And then I have x squared plus x and minus 6. X squared plus x minus 6. Then fx will equals to x plus 1. What's here? 6 is 2 and 3. We want to make a positive x. So x plus 3 and x minus 2. So what's the x-intercept here? What's the x-intercept? X-intercept is when fx equals to 0, right? When y equals to 0. So x plus 1, x plus 3, and x minus 2 will equals to 0. What x equals to? Minus 1, minus 3, and 2. So the x-intercept I have is minus 1, 0, minus 3, 0, and 2, 0. What's the y-intercept? You can tell me in half second. Negative 6. See the constant? Because when you sub 0 in, they're all 0, you're only left with negative 6. Okay, not sub into this one. Sub into the original one. The last number is minus 6. So the y-intercept is actually 0 minus 6. Okay, 0 minus 6. Okay, let's label everything here. Let's label everything here. X, Y axis, you have minus 1, minus 3, positive 2, and a negative 6. Okay, so we have negative 3, 0, negative 2, negative 1, 0, and 2, 0, and I have 0, negative 6. Okay, the next thing I will do is like, you know, sewing, like you have the needles, like you have a piece of cloth, and you want to go through all the holes. Okay, you want to go through all the holes. There are all the holes, that's the piece of cloth. The problem is, where do we start? Okay, where do we start? We will start all from the right hand side. Okay, all from the right hand side. But the difference is, do I start from the top or do I start from the bottom? Okay, the thing I will look at is the leading term. The leading term is positive. Okay, leading term is positive coefficient. I will start from the right top. If the leading term is negative, say negative 2x cubed, I will start from here. Okay, either here or here. It depends on the leading term. So, leading term. Leading term has positive coefficient. I will start from the top right. Okay, never start from the left. You always start from the right. Okay, top right. Okay, the next job is go through all these holes. Okay, go through all these holes. Okay, start from the top right. The first hole I'll go through is this one. That one, and I'll go to this one, and I'll turn back to go through this one, and then go back to here. Okay, the shape will look like this. You don't have anything else to go back, so it keeps decreasing, and that's why it will keep increasing. One thing you need to be aware of is it's not symmetrical. Okay, this graph is not symmetrical, not like projecting is symmetrical. So the turning point will not exist in the middle of those 2 points. I don't know where it will exist. You just need to show it's not in the middle. That's it. Like later in the second half of the year, we'll learn how to find the turning point. But now we don't need to worry about this turning point. Okay, we don't need to worry about this turning point. You just need to show it's not in the middle. That's it. Okay, for those two, it's not in the middle. It's slightly like different is alright. You don't need to be like really far away to that side, but slightly different. Another thing is a lot of students try to turn here. Okay, make the turning point exactly. I know it looks like a turning point here, but it's not actually the turning point. I don't know whether it's the turning point or not. So do not show your turning point on the y-axis. Okay, show your understanding that you know I don't know where is the turning point, and I just roughly sketch somewhere. Derivatives, like differentiation, we'll learn that like second half of the year. So we will work that out, but not now. Or another way is by using calculators. Okay, by using calculators, that's another way to do it. So there are 2 ways to do it, but we don't need to worry about the first way. I'll show you how to use the calculator to find it in a second. But you just need to know if there's no cast, I don't need to show the turning point, but you don't show it in the middle of the graph, and you don't show it on the y-axis. That's it. Okay, so hi. It's okay. We're almost finished. Okay, so that's how we sketch it. You can make the shape a little bit better than what I draw here, but mine's perfect fine. Okay, it's fine here. Okay, so that's the first type. Okay, that's the first type. When you have, okay, it's a cubic. At most, you will have 3 distinct factors. Okay, you have 3 distinct linear factors. Okay, the word is distinct, like different linear factors. The next thing I will show is you have repeated factors. Have repeated factors. Okay. I'll set up this box. Okay, x cubed, I will have 1, but there's no x squared term. You will have 0. X term, you have -3, and constant term, you have -2. Do not forget the 0. Okay, for cubic, you always have 4 numbers on the top, even though like I'm missing x squared or x term. You always have zeros. The number, let's say we try 1, -1, okay, -1, and we have 1, -1 times 1, -1 plus 0 is -1. -1 times -1 is 1, 1 minus 3 is -2, -1 times -2 gives me 2, 2 minus 2 is 0. Okay, thank you. Save us some time. Okay, so we have this. Therefore, fx equals to x plus 1. Okay, x minus -1, x plus 1. And then x squared minus x minus 2. Okay, directly work it out. To factorize this, you will have -2 is 1, 2. So you want a -1, so you need a -2. So it's x plus 1 and x minus 2. Okay, -2 plus 1 is -1. 1 times -2, it gives you -2. So you have repeated factors. Okay, for this case, as I said before, you can have 1 solution or 3 solutions. You can't have 2 solutions. It's not like exactly right, but it's still right. I still have 3 solutions for this case, but one of that is repeated. Okay, I still have 3 solutions because from x plus 1 you have x equals to -1, x plus 1 you have -1, and you have 2. You still have 3 linear factors, but one of that is repeated. I have 3 solutions, but 1 is repeated, so it seems like we only have 2 solutions. Okay, so when fx equals to 0, your x will be those 3 numbers, but it's actually minus 1, 0, and 2, 0. What's the y-intercept? 0, negative 2. Okay, y-intercept is that. Okay, let's put it here. Zero, negative 2, negative 1, 0, and too small. Half 2, 0, minus 1, 0, and we have 0, negative 2. Okay, we have 2, 0, minus 1, 0, and 0, negative 2. Okay, remember, if I have a repeated factor, repeat twice. Okay, I have a repeated factor, I repeat twice. Okay, x-intercept repeated twice. That will become a turning point. Okay, x-intercept, if you repeat twice, that will become a turning point. So the minus 1, 0 is actually a turning point. I label a turning point here to remind me that should be a turning point. Okay, another thing is, if x-intercept repeated 3 times, guess what that will become to? Quickly, give you 1 second to guess. Repeat twice become turning point. If I have repeated 3 times, what that become to? Yes, point of inflection. Think about if I have x times x times x, the 0 repeated 3 times, and that's that shape. Okay, the point of inflection shape. That will become a point of inflection. I will show you the case which is more helpful for sketch quartic. It's not really helpful to sketch cubic. So it's helpful to sketch quartic. So I will show you that later. But like today we'll finish up here. The leading term is positive. So I'll start from the top right. I'll go through here. I'll go to here. But that should be a turning point. I'm not go through it. I'll turn down here. So that's the shape of the graph. Okay, that point become a turning point. So at minus 1, 0, instead of go through, I will turn down quickly. Yeah, turn down at that point. So that's the shape of the graph.